In this episode of Lab Matters with me, Harriet Gould, ceramicist Alastair Bremner shares the story behind his revolutionary waste material tile company. Today, we have with us Alastair Bremner. Alastair is the co-founder and CEO of Elucid, a company that manufactures tiles. And it doesn't sound as it's not not all it seems, is it? Elucid. And we'll come on to that. Now, Alastair, we met not so long ago, and I can actually see some of the tiles behind you. And
You
they're
can,
similar to
you
the tiles
can.
I've got, but mine are sound. Mine was
Yeah,
sound related. Yours are.
yeah, yeah. No, these are left over from a Netflix project that we did for Netflix headquarters in Bristol, but we unfortunately accidentally made some the wrong color in the first batch, so I used them as a backdrop for behind my for
They're
video
very good,
calls. Yeah,
very good indeed. And that's exactly what I mean by things aren't quite what they seem when I say a tile manufacturer. You don't normally think of manufacturing tiles for Netflix, but and we'll come
yeah.
on to that. But before we get too into the cool stuff, not that your background isn't cool, but I do want to go back there. So
Sure.
tell me a little bit about that.
My background, yeah. Yeah. Where do you want me to
So
start?
we go back to school. I mean,
Back to school.
you were in Glasgow,
Yeah,
um,
yeah, in Glasgow. Yeah,
pulling off
I suppose
Ironbury.
first school first school I went to William Wood High School in Glasgow, which is in the south side of Glasgow. And yeah, what did I mean, I suppose I enjoyed school. Um, I
Any
think
particular subject?
well, I suppose art was was where I was most comfortable. I suppose art and design and in technical subjects. I mean, I suppose strangely I struggled with chemistry at school, and that's particularly bad since my father has a PhD in chemistry, and even taught chemistry at high school for a while before he went on to other things. But yeah, I was kind of dreadful at chemistry somehow, and it ended up being one of the subjects that I did end up kind of needing as part of my role as I moved on. So yeah, but I was I wanted to, I suppose art and design was the main thing I wanted to do, and I harbored some ambition to become an architect while I was at school, and even got so far as to being accepted to go to Dundee. But I also got accepted to go to art school to go to Glasgow School of Art, and I think I was probably most afraid of the maths involved in architecture. And also I suppose at the time, I have two uncles who are architects, and so it felt like, oh, that's, one very successful architect, and it felt that maybe a different career choice would be wise. And so and I have an aunt who was a professional ceramist and still manufactures ceramics, so it felt like that was a place to go. So I went off to art school to do ceramics.
You ended on
Yeah,
ceramics. And what
yeah.
so when you say you were rubbish at chemistry,
Yeah, well, I think I got a C. I mean, I wasn't dreadful. I mean, that was I passed it, but I wasn't. It wasn't yeah.
didn't
It
come
wasn't
naturally.
it wasn't that natural. I mean, yeah. I suppose I was never really dreadfully, academic at school. So art school felt like the right place to go, and that's kind of ironic because I ended up then going on to do a PhD, which sounds just like the kind of opposite from being very academic. But yeah, that that's a that was the that's what I went on to do after art school.
And then when you were studying, did you think about what you were doing as being something functional for the future, or did you have an artistic vision?
So I mean, I've always, I mean, when I was at art school, I really, when doing ceramics was really doing being involved in materials was really important to me, and so we really kind of got involved in again, I'm going back here now, but I was using limestone as a kind of material added into ceramics to add a kind of time lapse effect in ceramics so that it self-destructed is what I was doing as part of my degree show, which was quite good because in the end my entire degree show kind of self-destructed on purpose, and so I got that's where I got kind of involved in using cement fondues and materials that were used in the steel industry, and I got really interested in castables. Um, and yeah, we're just adding materials and unusual materials that weren't necessarily always weren't the traditional approaches in ceramics has always been my kind of yeah, interest in that side of things. So
Well, I
yeah.
mean, what do you think inspired that or gave you the confidence to try those
I
things?
don't. It was really the. I mean, it was kind of at Glasgow. There was a really. I had a lecturer, Bill Brown, who was who kind of allowed us the opportunity to do kind of things outside the box, and it was about really kind of throwing yourself into the materiality of the ceramic of the material, and yeah, so just kind of experimental process, and that kind of led on to yeah, obviously making artworks or PCs, but it was sometimes straight into functionality and sometimes into just for the sake of seeing what would happen. So yeah, that was encouraged, and I think that was one of the kind of going to art school, I suppose. It really did encourage it. Was I mean, thinking outside of the box is almost the sort of reason for that's one of the kind of skills that they teach you when you're there, not to necessarily just follow the rules, learn the rules, and then learn how to kind of break them along the way. And so I think that's kind of fed into some of the things, from then that kind of training and from then on.
Mhm.
If
And
that,
then, so when you graduated, what did you have a clear vision of what was next?
I no, I didn't really. I mean, I suppose it's like you draw. I mean, when you come out of art school on the other side, I didn't really have an exact plan. I'd won a prize to do a sculpture at Aberystwyth Ceramic Festival, International Ceramic Festival. So that was a time lapse sculpture that was going to fall apart over the course of the festival. So it's a 4 day festival run every 2 years in Wales, and I had this piece that was yeah, as I would say, was designed to break apart gradually. And one of the things about a ceramic festival is it was fixed on the wall. It's very difficult to describe these things. It was fixed on the wall, but parts of it would break apart and then fall off and crash onto the floor, which is not the usual sort of sound that you like that people um really like to hear at a ceramic festival. So big crashing ceramics banging on the floor. So that was the kind of and that was when I first met David Binns, who ended up being my director of studies on my PhD, and he was there at that festival and involved in running it, and so I met him there, but I think it was about 6 months later I saw that they were advertising for a funded PhD place at the University of Central Lancashire, and those were like, I mean, they still are like hen's teeth, but it was an opportunity to earn money and be a student and have my fees paid for. So it was at the time I was considering doing a master's, and it was a decision: do I move to Preston or Cardiff? And in the end, it was yeah, it was a sort of no-brainer, partly because one involved being paid to be a student, and it was it was a PhD opportunity to do a PhD. But until that came along, I hadn't really planned on it. It just sort of here's an opportunity. I think that's. I mean, I probably feel like these choices just kind of came, and I don't know. In retrospect, it feels like there weren't any other choices, but at the time there were different opportunities or different But yeah, it's.
Mhm.
So yeah, I did that and I applied and went for the interview and I had kind of built it on what I'd been doing and interest in materials and particularly in refractory concrete, which I was interested in at the time, and and that's yeah, that's I was accepted onto the course, but it was structured. So it was a practice-based PhD to look at you could we were designing the project around using this refractory concrete, which was a material which at the time was used in in the steel industry, or is was still used in the steel industry. But as the steel industry was moving abroad and contracting, along with it, the services and the materials which supplied it were declining as well, and they were looking for new opportunities that their material could be used, not in the steel industry or not in the traditional foundational industries. So my project was to try and look at alternative design applications for these materials, and they're quite very interesting materials. They're high alumina cement based, so they don't use the same cement systems that you use in traditional concrete, which means they're very high, very resistant to high temperatures, and so that's where what they're used. But they're castable, but behave somewhat like ceramics, but castable like cement. So there's somewhere between the two areas. And in actual fact, at the time, I mean, they've some of the technology that's used in refractory concretes is now finding its application in low carbon concretes as geopolymers and these sorts of things. So same sort of mechanism that's used or was used to set them as products is now being used as an alternative in low carbon cements. So.
And presumably they're still strong like cement.
Yeah, they behave in similar sorts of ways. So they have I mean, obviously, in the case of refractory concrete, you're firing the product, so you're taking it to a very high temperature, but they set in the same way as traditional as cements, and that you know they bond together just using through the reaction. So it's
And what
yeah,
were
that
you
that
using it for?
So what were we using? We were I mean, my project was looking at alternative applications. So into architectural applications. So could it be used to create facades, larger format slabs of material, casting it to create decorative effects, and then firing it to have the decorative, because you can apply glazes to them, and that's how yeah, that was the kind of the whole project. Also working with other artists and other designers to look at how asking them to use the material, and in some cases they'd never come across the types of materials that I was using, and see how they might use them to develop their own solutions to how this product might be find a new market or find new markets.
Does it, I mean, it seems to me that you would have to have more than a basic understanding of materials and their behaviors that you're more likely to get from chemistry to
Yeah, I mean, so
than
I was working with companies that were also which were manufacturing the products as well. So it was there was combination of both the chemistry that's involved, but also practical ways in which you can use the products in design applications. So it wasn't just about the material. That it was often about how you could use the material's properties to push the boundaries of what they were doing in terms of products and applications.
Hmm. I mean, I feel it seems like you're you saying that you had limited um talents in the chemistry department be a little bit, and even if you did at the time, perhaps they've evolved by
Yeah,
now.
yeah. I mean, they have. I suppose it's always been about. It's all. I mean, what and even what I'm doing now is engaged in the practical application of the science and what we're actually manufacturing. There are often what you can what you can do on what seems like the best thing in terms of from the chemistry or from what you've got, but what actually works in terms of practice, and there are various yeah approaches that we kind of developed that allow us to actually make the products that maybe the chemistry suggests might be more. Yeah, there are better ways, but the best way to do it is often I feel like I'm rambling here, but
You're not
yeah.
rambling.
It's
So tell me at what point did the idea for the tiles that you currently manufacture, the
I
con
mean, so as I say,
come about?
I was working with yeah, David Binns, who was my professor and director of studies, and he had been for some time working on manufacturing or making artworks and designing products that were made from glass, a combination of glass and ceramic. And we were often they were cast or manufactured or made in products that were using refractory concrete, and so we had a kind of synergy between what we were both working on. Um, and at the time there was a call out from Wienerberger, which is a very big brick manufacturer, in collaboration with the EKWC, which is a European ceramic work center in the Netherlands. And they had a project that was looking at redesigning the brick or reimagining the brick. And we sort of looked at that as we'd seen the call out, and we talked about how we might combine both approaches, as what he was doing on glass and ceramic, and how we could combine that with refractory concrete and castables to create different brick products. And so we applied and got the project, and that was I think it was a year long project, run partially there and in our workshops, and then and we presented the results to Wienerberger, and I got a first trip round they took us on a trip round the Wienerberger factory in the Netherlands, which was kind of a massive eye opener because it's just an absolutely huge factory, and I think it was ran by about two people. And I don't remember how many million bricks it made a year, but it was an insane amount of bricks. But there was almost, it was run by a couple of people. Felt like in the production, it was just super high tech, super scale production, and that was like, okay, there's an interesting thing here about how you could scale up what's out there in ceramics beyond where we were working in the university. So yeah, that was probably the start of us working together, and we established a silicate research unit, and then we really started to look at the materials we were using, and the combination of those materials, but at the same time being aware that we were often using materials that were mined or processed, and generating quite a lot of carbon in those processes, but the ceramic industry at the time was generating large amounts of waste materials that we thought might be able to replace some of those materials that we were buying from or sourcing or combining that were quite energy intensive. So it was that was the kind of that was the start, and we there was a call out, or I'd been to an AHRC conference to present some of my a paper on my PhD, and at the time, I'd seen the head of the AHRC was just presenting at the conference and was talking about how they'd just recently become the AHRC, and at the and that meant a change because they were now a research council, and previously they'd been a research board, and that's a subtle change, but it meant he was in the same room as all the other research board. So he was sat next to the guy who's from the nuclear research board, and all of the research boards in the same room in Whitehall. And he was saying that this new status puts a new pressure on us because really research in universities and research that the HRC funded needed to have a benefit, and it had to have and ultimately that meant either an impact or in economic benefit to employment and people. And I thought, okay, so the HRC is now moving maybe away from some of the projects they might be funded, but they might be interested in funding some kind of hard, more practical research that might result in kind of economic. So I went back, and me and Dave put together an application for an HRC funded project, and we were successful in getting that first grant. which is where we kind of started the journey to establish Elucid. But at that point, it was really just about, it was a project called the Aesthetic of Waste, and was about trying to source, looking at all these waste streams that were generated across what are called the foundation industries. So ceramic, cement, well, we weren't really looking at plastics, but paper industry, all sorts of industries that are the foundational industries of that go into everything we make. And so we were looking at these sources of these materials that were generated, that were quite high volume, had really high embodied energy because they'd been through quite heavy processing along the way. And they were, yeah, looking at how we could use them as to replace some of the materials that we'd been using for refractory concrete, or in the glass, and combining those together, and trying to use the properties of the material to actually hold the products together and reduce the carbon footprint that way. But also, I think at that point it was really also kind of recognizing that you could make products and materials from waste materials, but really it's important, if it's an architectural product, that it's a beautiful product that people want to have in their environments, wherever that may be. And that's we really had a focus on making sure that we made beautiful products and interesting products, and that architects and designers would want to use. And so, yeah, that first project started, and then we got to the end of we got towards the end of it, and we presented it, a kind of design. I think I can't remember now what it was, because I've since done lots of design conferences and trade fairs, but it was a kind of trade fair. I think it was called 100% Design in London. And we kind of presented it as a research project, but as if we were a kind of, this is the products we're making, and we got a really good feedback, and that led us we got feedback from everybody from Arup to I think that was our first. We met Starbucks at that, and their designers, and they said that, these are interesting products, and so that led us to apply for follow-on funding that was specifically about taking the research and trying to commercialize it, to turn it into a company that makes products. And we were still, I think, we were a couple of academics. We didn't really know anything about running a business, or about how we would even do it, but it was that's what we applied for the funding. And we managed to get the funding through, although they first denied the funding application, which is a lesson for anybody, I think. They said it was outside of scope, and we pushed back, and sort of wrote a letter back saying that it was in scope, and in the end, miraculously, they kind of agreed with the reasoning. So I don't know if that is it. I don't know if that's happened, if that was, kind of outside the normal way of doing things, but it ended up, it's probably down to Dave's power of, right. He wrote a, strongly worded letter, as it were, but justifying it, and so they gave us the funding. And then we went through that whole process, successful grant delivered, and then we didn't really know where we were going at that. We kind of got to the end of it. The funding had closed, or it was just about to come to the end, and it was like, what are we doing here? And we were we had an exhibition in the university to kind of present the results of the research project to the rest of the faculty and so on. And at that time, a guy called Neil Crabb walked through while we were setting up the show, or I think, or just finished it, and he was from a company called Frontier IP that specialize in commercializing research from universities, and he was at the University of Central Lancashire to pitch for being the commercialization partner for the university, and he was just getting a tour and just bumped into us, and that was, we struck up a conversation, and he thought, oh, this is interesting. I think this might be something we might be able to get funding for, and asked us a lot of searching questions about, was it protectable? Did we have a patent? How did we do this? And have you told anybody about it? And what have you told them? And all sorts of things that we hadn't really thought about. And so yeah, that was kind of the start of kind of a different, yeah, you know, for myself, it was like, okay, now, we had a lot of conversations after that with the university involved about how we would spin the technology out, how it would be done, and there's a whole big long story about that.
Mm.
I won't go into, but we ended up I ended up so Neil and myself went down. We went on a kind of roadshow, what's called a roadshow, to pitch the company to some potential investors. I think we saw 10 10 or so investors over a few days, and in the end, we raised about, yeah, 200, I think it was 200 and 250,000 or 268,000 from a number of different investors to what seed funding to establish the company, and that was what happened, and so it was suddenly I was seconded from the university to be the I think it was, at the time I wasn't CEO, but it was project manager on getting the company up and running, and we found a small unit on the edge of Preston, and we had a kiln we had lined up which we knew existed, that was large enough scale for us to be able to start pilot production and that sort of thing, and we kind of went on from there.
Mm.
That was the start of it, but that was a while ago now, 2015.
Indeed, and it's gone from strength to strength, as it were, ever since. And you've got some pretty, you've already referenced a couple of them, Starbucks and Netflix. You've got some very well-known customers on your book.
Yeah, yeah. So I mean
What does
that's taken. I mean, how's that come about? I mean, it's been, I'd say, 10 years, roughly 10 years since we started. I mean, there's been a lot along the way. I mean, initially, what we thought is that we would have to design and build our own factory. So we didn't know how we would be able to manufacture our product to scale it up, and we were always clear at the start. It was started in a lab, in a small, in the circuit research unit. Products were made on a small scale, but we knew in order to do it on an economical basis, we'd have to do it on a large scale, and so we started with we did a lot of trials with a company out in Italy called Sacmi, which is one of the largest tile making equipment companies, and we did a number of trials with them, to essentially establish how we would make the tile, and how much a factory was going to cost, and it came to quite a large sum, around 10 million quid or something, I think was the initial quote we got or indicative quote for a factory. And we thought, okay, there's a big gap between what we're doing now and 10 million pounds, and then you've got to sell what it makes, and it was going to make a lot of tiles in a short period of time. And so that was when we started to look at how we could manufacture at scale using other people's plants, because it also felt like, okay, this is not necessarily the way we should go, because there are factories out there that if we can plug into them, then we can really scale up a lot faster, without having to spend 10 million pounds, which felt like a much better idea. But turns out it's not so easy to just get like people to let you come into the factory, and here's this material that you've never come across, that we make, and it's made from all these recycled materials, and here's the data sheet, and yeah, we can use it, and here's how it performs, and this is how you're going to press it, and yeah, so we've been working in Spain, for about, yeah, so probably for about, yeah, 5 years or so, trying to establish get the scale up, getting it working in various different companies to manage the production. I mean, what we do that's very different from other companies is that we use recycled materials, so our tiles are at least 95% recycled, which is some of the highest percentages on the market. Our floor tile is 98.5% recycled. But the really different thing that we do compared to what other tile manufacturers do is we skip out the spray drying step, which is a really energy intensive production process that almost every tile in the world uses, which is ball milling, raw materials or milled, water is added, and then they spray dry it through a giant tower with gas burning at the bottom to take it from around 35% moisture down to around 5% moisture. And that then is the materials that's used to press pretty much all the tiles in the world. And we completely skip that whole production step out, partially because the materials have been through that step in other parts of production with other companies, but also it's so instead of adding the water and then taking it away, we're just we add the water and granulate the material to create something which we can press on existing production lines, which means we were able to scale up the process really quickly, and it approximately it means we're around half the carbon footprint compared to other ceramic tiles, but we also use around half the water compared to other tiles, and that's increasingly becoming an important aspect around the world, but definitely in Spain, water use is becoming really important. So yeah, that's been kind of a yeah, it's been that's been a real challenge, like in terms of getting into factories and working with factories to be able to make product, and then along the way we started and established a relationship with Tops Tiles, which has been really key to enable us to be able to do that. So we have an exclusive relationship with Tops Tiles in the UK, and
We
it
can
would have
buy
been
the
really
tiles. We can
you,
buy them domestically.
where you can buy the tiles. Our Principal was our first wall tile range, which is available, and then Mass, which is our floor tile, which launched just at the start of the year, basically in January, and
Now I've seen
is
some samples of these tiles, and they really are wonderful to look at. And you wasn't there was something like non-slip qualities, properties to the floor tiles as well, and
yeah. So I mean that's because we've as you mentioned, we've got commercial customers like Starbucks, and yeah, the tiles are have got a non-slip coating or surface, but it's also easy to clean. So it's a 5 stain resistance. This is turning into a proper sales pitch here now.
yeah, it is. We
But
should,
yeah,
if you're
it's
interested, you can look at the website Elucid, which is alusid.co.uk. I'll go and have a look. But
there
yeah.
you go. Yeah, you can see a full range. I mean, you can see. I mean, not just product. I mean, obviously we sell products in Tops, but also we make a number of other products on our website, which are all made in the UK. So we kind of, in the moment, what we do a lot of is we do a lot of design development of products in the UK, and we do a lot of the formulation of the raw materials and a lot of the tests and making sure it all works here. And we do a lot of kind of the more kind of bespoke and higher end stuff we manufacture in the UK and the majority of the tiles are made in Spain at the moment, because it's just we're plugging into where the raw materials are, and the full ecosystem that's out there that enables us to make and design and produce ranges of products. So
So
yeah.
what do you think is the next step?
Well, I mean, for the next step for us is we're kind of we've established we got the first wall tile, and then we've just launched the floor tile. There are two things that we want to do. The first thing is to increase the size of the tiles that we manufacture. Our commercial customers really want us to be producing tiles which are larger format, which sounds like it should be easy, but it adds a lot of complexity in the production process. There are lots of things that we need to manage to handle along the way, to produce them consistently in thousands of square meters at a time. But we've got a project which is working on that, and so we hope that's going to be in place we're looking to launch them this year, I hope. And so it depends on how the industrial trials go. And then the other thing that we're always working on is developing new ranges of what we, in the scales and the sizes that we manufacture at the moment. So we're in the tile business, and we use very different um, methods to manufacture the raw materials, and but ultimately at the end, it's the bit that you see is the top surface and the product. So we're really in the design business as well. So we're looking at different products, finishes, glazes, and developing a number of different ranges. I can't tell you too much about them. One we're working with a company in the Netherlands, and it's going through its final industrial trials and should be launched before summer. And other ranges are kind of top secret and in development, but yeah, so that's the kind of that's the exciting bit, and testing things, putting them through the kiln, and seeing what comes out the other side, and then testing it with our clients and customers to see if they like it, and they're willing to buy it. So it's trying to combine all those different things together.
Well, it sounds like that. It sounds like you're putting your schooling to exceptionally good use, and you get to scratch that artistic itch at the same time.
Yeah, yeah. I mean, yeah, I don't know. I'm certainly wasn't a very good artist, so I'm probably more. I don't know. Now, I don't know if I'm a good entrepreneur, but I've certainly kind of accidentally become an entrepreneur along the way, and yeah, that's
Seems to be
yeah,
going. It seems to be going in the right direction.
it's certainly going in the right direction. Yeah, yeah.
Good. Well,
It's
I
it's
will
been a
watch.
roller coaster ride for sure.
They all are. I will
Indeed.
watch. I will watch your progress with interest.
Yeah.
Alistair, it's been a great pleasure to have you on. Thank you so much for being with us today.
No, it's been great. Pleasure. Thanks, Harry.
Did you enjoy that episode of Lab Matters? If you did, please do send it to the people that you think will enjoy it the most.